Hi everyone, have you ever wondered how physics work? I did too once, but then salvation was delivered to me by a man known as Mr. Gaffey. And today, I deliver it unto you. These are Newton's 3 laws of motion. First law, objects at rest stay at rest. Objects in motion stay in motion, unless acted upon by an outside force. This one is pretty simple. The first part is basically just saying that if you set a brick down on a table, it's finished there forever unless someone pushes on it or something. The reasoning behind this is that the forces acting on the brick when it is at rest are a normal force from the table going upwards and gravity from the earth going downwards. And that because the two are equal, the net force acting on the brick is equal to 0. And because the net force is 0, the brick won't move, which makes intuitive sense. If you give a little push to the brick, you'd be creating an unbalanced force going in some direction which would cause the brick to move. The part that tricks all those period 1 kids out is the law stating that after pushing the brick, it will keep going forever and never stop unless acted upon by an outside force. This, like many things, can be more easily explained if it happens in space. In space, there is no gravity acting on the brick and no normal force, so here we just have a stationary brick. Then, we have someone push on the brick and it begins to move. Because there are no forces in space, such as air resistance or friction to slow the brick down, it will continue to travel forever. Now, when we go back to the table example, you're finna try and pull that thing where you push the brick, and after a while it comes to a stop, and you're finna say that Newton's first law is a conspiracy, get punked. Well, actually, you'd be the one getting punked, because you left out two hella important things. First one is friction, which is acting as a force opposing the push. And now you're finna say, oh yeah, well see, even though the forces acting on the brick are unbalanced, it still stops, get wrecked. But then I would point out that there isn't actually any force pushing on the brick to the right anymore. There was when we initially pushed it, but that was only for, say, 1 second, which caused the brick to move at like 2 meters per second. And now the only force acting on the brick is the friction, which isn't actually stopping the brick, it is decelerating it at a slowly increasing rate. Force equals mass times acceleration. Essentially, you have some dude who's like, dog, I have this ball and it has 10 kilograms of mass, and I want to accelerate it at 2 meters per second, but I don't know how much force to apply. Then you say, oh, well, a mass of 10 kilograms times 2 meters per second is 20. Therefore, you must apply 20 newtons of force to accelerate the ball. There's also another version of this equation, which is the one you see on tests, which is acceleration equals force divided by mass. You create this by algebraing the first equation, then you get the new one. This one actually makes a lot of sense if you think about it. Essentially, you see that basically if you have some force applied to some mass, it's going to have some acceleration. And then if you have hella force applied to some mass, it's going to equal equally hella acceleration. But by contrast, if you add hella mass to some force, you end up with equally hella less acceleration. There's also another version of this equation for mass, but you can figure that out yourself, dog. Third law, every action has an equal and opposite reaction. This one's actually pretty tricky. Basically, the idea is that every force going to the right creates an equal force going to the left, and so on for other directions. This can be pretty easily observed by two people on an ice rink. If one person pushes the other, he delivers a force of, say, 50 newtons to the person going to the right. But in doing so, he also applies 50 newtons of force on himself going to the left. That's why if you push someone on an ice rink, you both end up sliding in opposite directions. I think that happens in Eternal Sunshine for the Spotless Mind, but I can't find the clip. The part of the third law that punks all those period 1 kids is the part where we say that basically, the Incredible Hulk punches a kitten in the face. Who is applying more force? The Hulk or the kitten? And then everyone says the Hulk is obviously applying more force, but the real answer is that they both apply an equal amount of force on each other. In this case, probably a billion newtons. And then you think, well, how is that possible? Because the kitten is probably finna go hella flying, and the Hulk is just going to be sitting there, seemingly as though he isn't having any force applied to him at all. In this instance, the thing to remember is that the Hulk has way more inertia than the kitten because of his hella mass. And this amount of inertia makes him way more resistant to change in motion, whereas the kitten has less inertia than Call of Duty Infinite Warfare has positive reviews on Metacritic, and finna goes hella flying. Anyways, that's about it. Thanks for watching. I hope that Mr. Gaffey looks over and gives me a thumbs up or something so I can feel validated. But chances are he's just going to gas my project for having hell errors on it, but I don't know. Also, sorry to all the period 1 kids. I kind of roasted you, but you guys are actually probably pretty cool. It's just a joke we period 2 kids have.